So tonight's talk is on performance testing and diagnostics, and it's using 3 different open source tools that are, I think they're all written in Java. That's JMeter, VisualVM and Eclipse memory analyzer tool. And I'm Ruth Mills, and I'm one of the lead developers at Connect Group in Trinity Park in Birmingham, and I work on agile projects for Jaguar Land Rover, mainly sort of like web app development for JLR. And so I'm going to start off with why we need to do performance testing, and an example of that personally is that a few years ago, it must have been around about 8 years ago, I set up a website called Salon Guinea Pig. And the idea behind that was that there were all these like trainee beauticians and hairdressers that were desperate for models to practice the haircuts and the beauty treatments on. And likewise, there are lots of people out there that are after cut price or free treatments. And so the idea of the site was to bring the 2 groups of people together. But then back in 2013, about 3 years ago, it went on Channel 4's Super Scrimpers, I think it was. And as soon as that happened, there was a massive rush of people to get onto the website. And not surprisingly, it crashed the site. And there was also some really weird behaviour with connections to the XML database that it used, because it uses the Exist XML database that's an open source database. And what was happening was that it was getting in a sort of deadlock condition where all these Unix sockets were ending up in the closed wait state, and the only way to fix it was to restart. So that is the sort of use case that this sort of performance testing would nail before you've got that sort of environment out in the wild and you get all these people hitting the site and then it dies on you, just at the point where you're hoping that everybody's going to be clicking on all your Google adverts and making you some money. So thankfully, I know now what to do should I ever have a similar situation in the future, except I ended up selling that website to some Australians a year ago, and I think they're sort of relaunching it at some stage shortly. So the first use case for performance testing would be to test an application under heavy load where you wouldn't normally be able to do that unless it's mentioned on TV, for example, or if it was the example of Ticketmaster, if there's a Take That concert on that everybody wants to book tickets for. So the idea is that you can simulate having gazillions of users on the site all at once using automated tools, and that can then also track down bugs and issues that you're only ever going to get under that sort of heavy load that you'd never normally get just with normal testing. So if you just got manual testers on the site, they wouldn't be able to hammer it anywhere near fast enough to simulate those conditions, but you can do it automatically. And also, by sort of tuning the number of threads that the number of requests per second that you're firing at from your automated tools, you can track down the point at which the application starts to fail under stress. And you can also test that if you get to that point, then it fails gracefully. So, for example, with that Salon Guinea Pig site, one of the changes that I made was that if there were more than so many connections to the XML database concurrently, rather than trying to create more that could cause the deadlock condition, it would instead just return an error message saying, sorry, please try later, we're a bit overloaded. And then also, if you're making some performance critical changes to an application and you want to verify that they have actually improved performance, you can benchmark the performance before you make the changes and then do so again afterwards. So basically run the same script before and after, and you should then see that afterwards the script is taking less time to execute. And if it isn't, you know that the changes that you made have actually made things worse, in which case it's okay, what's gone wrong? So the first tool that I'm going to demonstrate tonight is JMeter, and that is a load and performance testing tool. That is the tool where you set up the the threads that are going to hammer like the web application. I mean, it doesn't just work for firing off HTTP requests. You can even do things like firing off database connections, FTP connections, all sorts of different things, although my demo is going to focus on HTTP connections in a web app. So it's written in Java, and it's extremely comprehensive and configurable. I'm probably going to only touch on a small amount of what it can do tonight. And what I really like using it for is firing up lots of different concurrent threads. So it'll like totally max out the application, throwing more threads at like the Tomcat server than you'd expect it to ever handle. And that's really good, like I said, for just seeing at what point it fails and if it does so in a graceful way. Then the second tool is VisualVM, and the idea with this is that you connect VisualVM to the Java virtual machine that's running your application, and it will do things like monitoring the CPU usage, the memory usage, the number of classes loaded into memory, and the number of threads in the JVM itself. And so that's really good for tracking down things like memory leaks, because you'll see the memory go up and up and up if there's memory leaks. And if you've got bottlenecks in the code, you'll see the CPU usage go up a lot. And you can also do sampling and profiling, and that lets you drill down into the, like at the individual method level within the Java code. So you could say, okay, this particular method is taking up most of the CPU cycles, therefore there's something in this code and this method that I need to look at to fix. And you can also generate thread dumps and heap dumps. And heap dumps are really useful because that will give you a snapshot of what things are in the memory in the JVM at that moment in time. So you can then open up... Oh, wrong slide. You can open up Eclipse Memory Analyser tool, which is the third tool I'm going to come on to, and that lets you open the heap dump and look at all the different Java classes and objects in memory and see, okay, this class has got the memory leak, because you can then sort of like drill down into the different classes, and it will even sort of like predict which classes are most likely to have memory leaks, so you know where to look at a high level before then drilling down to a lower level to do so. The only issue is that if you've got a Java virtual machine that's several gigabytes in size, then it can take an awful amount of time to read in that heap dump and analyse it, as I found out a couple of years ago when I was like tracking down a memory leak in work, where I think the heap dump was about 8 gigabytes in size, and because I think my Mac only had 8 gigs of RAM, it totally maxed out the Mac even after trying to load the thing for 20 minutes or more. And the previous slide, that was... oh, wrong screen. Wrong button. Previous slide was just about how to connect to a remote JVM from VisualVM. Suppose that the application is running on a remote server, such as in the cloud, and you want to connect to that machine to analyse what's happening with the memory and the CPU usage. You can do so by setting up a SOX proxy over SSH. So it's like doing SSH tunneling and setting up a proxy through that. So that'll let you tunnel into that JVM and connect securely from anywhere, basically. Now, to get a heap dump, which is the thing that the Eclipse Memory Analyzer tool needs, you just need to add that option onto your parameters for when you're starting the Java application. Or you can run a command line tool called JMap, and you just give it the process ID of the JVM. Or you can trigger a heap dump from within VisualVM itself, and it's the third technique that I'm going to demonstrate because it's a lot more straightforward. So now I'm going to come on straight into the live demo, and that's going to show all three tools in action. So I've got a Spring Boot web app, and I'm going to fire off JMeter at it to show what happens when it's under heavy load. And then I've got VisualVM that I'm going to fire up, and that will track down any performance bottlenecks and memory issues. And then finally I've got the Eclipse Memory Analyzer tool, and I'm going to generate a heap dump and then analyse that, so I can show you how that tool will show how to track memory leaks also. So here's JMeter, and there are 4 web requests that I've set up. So the first, the first is called Hunky Dory, and the idea behind that call is that it's simulating like a happy path of you making a web call and it's returning pretty much instantly. Then there's one that I've called Leaky Cauldron for any Harry Potter fans out there. That simulates a memory leak. And then Slow Loris, that prints out a load of log statements to try and use up as much CPU time as possible without doing anything useful. And then finally there's one called Easily Overloaded, and with that, if it has more than a certain number of concurrent requests, it starts throwing errors back at you instead of returning the 200 code. So I'm going to fire that off shortly now. And there's a summary report, and that's sort of like showing what's happening. So like you've got the number of samples, you've got the average time, I think in milliseconds, the minimum time, the maximum time, percentage of errors, the throughput, etc. So while that's going on, I've got VisualVM here, and I'm going to restart that so we can bring it up from fresh, just so it connects to the right thing from the word go. So I'm going to connect to the performance testing application. And so the monitor, this is really useful. So this is showing what the garbage collector is doing, how much of the CPU that's using. So the CPU usage is in the orange and the garbage collector is in the blue. So at the moment it's pretty happy. And then on the right, at the top right, you've got your memory. So you've got the total heap is indicated by the orange, and then the actual amount of heap memory used is the blue. So that memory is gradually going up, which would indicate that it's getting more maxed out and also that there's a memory leak. And then that's the number of classes, and then that's the number of threads that Tomcat is running. So as the application's getting busier, Tomcat is starting more threads to deal with all those extra requests that are coming in. If I go onto the threads themselves, so I think HTTP and IO, that's like the native input-output for the HTTP, so I think those are like the worker threads that are processing the web requests. And then there's like other things like the JMX thread, TCP connections, etc. And then with the sampler, you can start, if you click CPU, this will show you where most of the time is being spent, and it's actually in output stream append to stub append by the look of it at the moment, which I think is where it's like writing stuff out to the output stream to go back to the browser. And then you've got like the memory usage also. However, it's not very useful at the moment because it's just showing you everything. Whereas if I go onto settings and I tell it to only, I think I've got to stop it first and then change that so it only profiles stuff in com.connect group. Same with the memory. And if I restart that now, then you can see that now it's only monitoring the packages in my application. There's one package, there's one class in particular that's really, really hogging all that CPU time. And if I click on that, try and work out which class that is, it's being silly. I'll just pull that down. Then it's slow Loris service impl, and it's in a method called go slow. So I'm going to go to the code, and I'm going to pull that up and show you exactly what that's doing. So basically it's in a loop that's printing out I'm busy doing nothing, busy the whole day through, trying to find lots of things not to do. So it's basically wasting as many CPU cycles as possible just to show you an example of how the tool has managed to track down something where the developer should have just got rid of all those debug statements before it even got out the door. So then going back to JMeter, that's throwing lots of threads at that now. So what I'm going to do now, I'm going to stop JMeter temporarily. I'm going to stop the application, and I'm going to basically comment out that loop. And then I can restart it. And so this is like the statistics after having run all those JMeter tests. I'm going to click on this broom thing to clear that down, and I'm going to fire it off again now. Yeah. And hopefully, you can see the difference in speed. It's going so much faster now. That thing isn't clogging it up now. Thank goodness. So if I go back to VisualVM, I have to reconnect now because it's a different instance of it. And if I go back to the sampler again and only go com.connect group .star, go on to CPU sampling. I need to stop that wrong button and do it again. Only connect group packages. Then this time, what class is that? It's on a different service now, the easily overloaded service that I called it. And if we go back to JMeter, then oh, it's finished already. That was quick, goodness. So the easily overloaded service is showing an error rate of 39.6%, whereas everything else has got 0 errors. And I'm going to bring up the code for that easily overloaded service. So as you can see, it's got maximum number of connections defined as 1, and then if it's got more than 1 connection, it will throw an exception saying, sorry, too many concurrent connections. And then otherwise it increases the connections. It sleeps for 100 milliseconds to simulate waiting for something to come back from the database, and then it reduces the number of connections. So if I then go and make that, say, 100 and restart the app, and then I'm going to reconnect from VisualVM. Restart JMeter. So now easily overloaded, hasn't got any errors yet at all. Whereas, last time it was coming with like 39% errors. So it's like by increasing the number of connections allowed, that's fixed that bug. And so JMeter would have flagged that as being an issue simply because it's showing that many errors cropping up for that particular call. And let's have a look to see what the memory's doing again. So at this point I'm going to take a heap dump while it's still running. I mean, this tool will actually do something similar to what Eclipse Memory Analyser will do as well, and that this will also analyse the heap dump for you too. So again, it'll show you which classes are using the most memory, etc. But what I'm going to do now, I'm going to get Eclipse Memory Analyzer tool running. Which is this. I can actually acquire a heap dump from this as well. So you can actually use the Memory Analyzer tool to get the heap dump directly rather than having to find it on the file system if you're not sure where it is.
So Ruth, what is a heap dump?
So a heap dump gives you the contents of the memory of that Java virtual machine, so all the different classes and objects in your application. Because in Java they've got a part of the memory that's called the heap, and that's what gets allocated dynamically when you start up the JVM. So you can actually specify like the minimum and maximum size you want for the heap in that Java virtual machine. And if it goes beyond the maximum size, then it will fall over with an out of memory error. That's okay. Sorry, I should have been clearer.
No, I thought it might be a data dump.
The heap dump is basically just a snapshot of everything that's running
Yeah.
in memory at that moment in time.
Okay. Oh, thank you.
That's okay. Sorry if I'm using like too many sort of like Java specific terms as well. If I am, just please tell me, because then I can like explain just like I did then. So now this is analysing the heap dump of that application. Here we go. And I'm going to go straight for leak suspects. Gosh, 1.6 gigs, that's big. And it's gone straight to it. So it's gone straight to leaky cauldron service impl, occupying 1.6 gigabytes. And if I bring that code up, then what that's doing, it's every time it's getting a web request, it's going through this 5,000 times, creating a new string. A memory charm is stealing your memory. It's appending a random number onto the end of it, just so it doesn't put the same constant into, memory over and over again. So it's actually putting a new string with that in it every time, and then it's like logging the size of the list. So it's actually got how many? 1, 2, 3. It's got 10 million of those strings in the list. That's why it's taken up like 1.6 gigabytes, I think. So again, Memory Analyzer's just gone straight to where the memory leak is in the code. So now if I don't make it add it to the list, and start it up again, and I'll let JMeter do its thing. So now I think things are going to be a lot happier. It's going to get to 2,000 requests so much quicker now. But while it's doing that, I'll kill that heat dump, and I'm going to take another one. And hopefully this should be quite a bit quicker now because it's not got all the memory leaking. So go on to leak suspects. That's looking a lot healthier now because it's just saying it's the class loader that's taking up most of the memory, which you'd expect because that's got all your classes in anyway. So by rerunning the memory analyzer, doing another heat dump, after fixing the bug, it is showing you the bug's been fixed, and you've got a much more normal result coming through from that now. So that's basically the 3 applications in action, tracking down bugs, and then being able to like retest the bugs once you fix them, to make sure that they are actually fixed. So are there any questions on that, please?
So with the Eclipse one, is
Yeah.
that a standalone tool or is that part of the audio?
That's a standalone tool you can download separately to the IDE. So I think what they've done, they've like used like Eclipse RCP to create a tool that's specific to like analysing heat dumps and tracking down memory issues. Oh, garbage collector, yeah. Okay, so in Java, when you've like created some classes in memory, some objects in memory, and when the code is finished with them and they go out of scope, Java automatically garbage collects objects that you don't normally need periodically, as opposed to like a language like C++, where in C++ you've got to explicitly delete memory that you've allocated to objects yourself in the code. But in Java, you've got to rely on the garbage collector to do that for you. But you can still get memory leaks, as we've seen, if you've got like object references and things like lists that you're not clearing down when you should do.
Demo does the issues, fixed it, implemented it, and then retest. Now, in project terms, how long is that duration? And in your experiences, how have these affected in terms of, because I can see that yes, there is a performance issue in some cases. Now, the first thing is, who determines what is performed? Because as a developer, you would obviously be using these tools on a day in, day out basis to identify that the environment that you're developing in, it is performed. Are you then given the simulation like or an environment which is more production like for you to be able to test these and then decide what is the optimum configuration to like or performance or feature is like? Now, my questions have always been how do you get to optimize? There will be many parameters that you have to go through.
Exactly.
Identify what is the right value for you to look at, and who determines whether it's a bug or whether it is something that you just basically want to enhance. So how do you deal with it? How do you sort of look at it from a point of view? Perhaps I'm not sort of putting it right.
Okay. So I'll try and like use a real world example. It was like a couple of years ago. I was working on a web application, and there was a sprint, an agile sprint that was dedicated to performance testing and tuning. And so within that sprint, I was testing the application on the dev environment with JMeter and with VisualVM. and that did point to the performance not being as good as what we thought it was. I think it was probably about 5 or 6 times slower than what we thought it should have been. But then by using VisualVM to work out which classes were taking up most of the time, even running it on dev, I was able to find out which bit of code wasn't optimal, and then I could fix that code, redeploy to dev, and then rerun that, and then find it was doing 50 requests per second as it should have been, instead of say,
for a tester. Because you have got certain parameters to evaluate on determining whether it's performant enough or not.
Yeah.
How is that translated then to a tester? Because a tester's expectations might be different to what yours are. Now, have you seen that a tester who has got this sort of a background, do their expectations generally align to what yours are? Do they vary a lot? Or they have got no clue as to what is performed?
I guess ideally then, there might be some criteria from the business that states what the minimum level of performance should be initially. So it might be, the business might say, okay, I want 100 requests per second, and so that then the tester would test the application to verify that it's then pushing through at least 100 requests per second. But I think ultimately, that's where you definitely need teamwork. You need testers and developers talking to each other.
Okay. Now, in terms of given a requirement by the business, would you then go to, let's say, 150% or 200% of what it says to say?
Oh, definitely, yeah.
So is there a sort of, who decides this break? Is there something which is decided collectively as, 150% is good enough or 200% is good enough?
Now, the way I would do it, I would actually increase it until it starts to break. So
you basically just put out numbers saying at this point this starts to break.
So it might be like doing a binary chop on it. So it could be, say, okay, double it. Does it still work? Yes, it does. Double it again. Does it break? Find a point in between the two, and then do a binary search to find out the point that it then falls over at. Would be one way of looking at it.
I think I sort of get a good understanding of how that would basically work. In which case, a tester's role would probably be, okay, this is the point at which it breaks down.
Yeah.
Is this a point good enough for a business as a put forward as a case for them to say, actually, I'm happy with that performance, and then you basically then refine your requirement to say,
definitely. I think you've stated, I think between us we've worked out that sort of technique. So it will be to use that binary search technique to try and find the precise point at which it starts to fall over, and then we can report that back to the business, and then say, okay, is this satisfactory, and if not, where do we want to be looking to, what sort of level do we need to achieve?
So you basically go through each of your process doing stress tests, finding points of failure, and then go through some sort of loop with the development team, the analysis to see if it's a defect or not, and whether it's just the actual system load at that point. Go back to the business and say, this is where we're at.
And of course, the other way of doing it is with the benchmarking, where it's telling you what the throughput is in terms of requests per second. So it's putting 2,000 requests for each of those URLs through, and then it's working out, okay, so the average throughput for each is about 29.5 per second. So it could be then, okay, I want to increase this so it's, say, 40 per second is the benchmark that I want. So again, that's the example of, okay, before and after, am I seeing an improvement for the changes that have been made?
Okay, would you be doing this in the prod environment as opposed to a test or pre-prod?
I think for the bench,
if you're doing that sort of activity with the whole loop system, then you're going to have to be sort of really putting stuff into prod. I suppose if you've got mechanisms to be able to do that, then it's not so onerous, but obviously if you're doing this as a sort of precursor, then it's probably seems safer to the visual.
Yeah.
Obviously it depends on the environment you're running.
I guess so. But I mean, obviously the last thing you want to do is to run a test on live when it's live that could make it fall over when there's clients looking at the website, when the visitors to the site. So I guess if it's a clone of production that's like the same server setup, the same resources, same hardware, then that will give you like a representative idea of how it would then behave in live, if it was like a clone of live, say.
I'm just wondering, because I've actually seen performance testing in live, but out of office hours.
Yeah, I mean that's another way of doing it as well. So either do it out of office hours or do it on a clone, unless you're totally sure that it's not going to break the app. So if it was like a benchmarking test where it's like putting a limited number of requests through to work out how long each request is taking, that would be satisfactory to do on a live environment. But if it's really maxing it, then you don't want to do that when it's going to put the business at risk.
It obviously does depend on the application and
Yeah, cool, it's alright.
In this test plan, this is testing all the three performance.
Sorry, what was that?
We are doing performance testing.
Yeah.
So is it including all stress, volume and load testing? All the three components, or are we doing individually? Like there's three testing in performance system. That's what my understanding is.
Yeah.
Like there's load testing, stress testing, and volume testing.
Yeah.
So this test plan that you have shown, does this cover all the three?
I think it would cover all the three, yes, yeah. I mean, I can go into more detail if I like click on an example. For the so you've got the idea of the thread group, and that is saying, okay, I've got 20 threads. I want to fire up no more than 20 threads, and I want to take a minute to ramp that up, and I want to have 100 requests from each thread. So by tweaking these parameters, you could then make it go from like a load test to a stress test and so on a performance test, just by tweaking those parameters. So if you wanted like a proper stress test, you'd have as many threads as possible. If it's a performance test, just to see how it behaves under representative conditions, you'd create as many threads as you expect to have requests happening on that server, and so on.
How do you report?
So,
How do you report this to a manager who is not technical enough, who doesn't understand any technicality?
I'm going to try something quite random now. If I go on to, let me see, sample preprocessors. Let's try response time graph. No values to graph. I might try rerunning it and see what that does. Because there are like sort of like different sort of like reports you can add as well. But I've tended to mainly use the summary report so far because that just shows things in quite a straightforward way quite quickly.
No, but in this case, for example, I
Yeah.
don't contract with you, but I think the one you mentioned was one of the throughputs, was a key element for you to evaluate.
Yeah, the throughput, yeah.
Now, what would that mean for a non-technical manager who would be interested in ensuring that
Yeah.
your website, web app is suitable enough for hundreds of thousands or even millions of people to start accessing at the same time? How would you put that across to them?
I would say, okay, so this site can handle 29 hits per second to that manager. I would put it in those terms to that manager in that case.
But is this something which is basically then straight out of the tool, or is this something that you have to work out?
That'll come straight out of the tool.
Ah, so
Oh, it's sped up now, it's doing 31 per second, that's good. But has it done me a graph of response time? Yes, it has. So it's saying that the response time is excellent. It's shown that the response time for the easily overloaded service is just over 100 milliseconds. And if I go on to that class, that's the one where it's got the weight of 100 milliseconds in time. So that graph is correlating exactly with what the code's doing. It's taking just over 100 milliseconds for calling that request, whereas for the other links it's just above 0 because they're just doing pretty much nothing. And the red one is leaky cauldron, which is just like, appending a few strings together, whereas the other two are doing nothing at all. So so that graph is another way of like showing visually what the application is doing, and it is correlating with what I understand the application to be doing as well.
and for testers who are interested in getting into this aspect of testing, what would you advise them?
Well, because all these tools are open source, I just advise sort of like downloading, say, JMeter and looking for some online tutorials on it, and just have a play about with it, even if it's just like firing off a few requests at Google to see how fast Google's responding initially. Although don't try and denial of service attack anybody with it, because that would be very nasty. I mean, I suppose potentially you could use it to do that, but I'd advise strongly against doing so, obviously, but yeah. But because they're all open source, definitely download them, have a play with them, and then look for online tutorials to get the best out of them as well.
Because I think it is pretty apparent that in order for us as a tester to be able to get to that level of skill set, quite a lot of development experience
Yeah.
with at least a few programming languages from one, and proper understanding of what is behind the scenes
Yeah.
that would come in. I mean, even if we have a tool for a novice, this is probably of no use, just downloading into that is not what you want to do with it.
Yeah. So I think if it's a novice, then the JMeter is probably the most relevant tool, which is just the one for firing off the request and the load testing, because you can use this tool without needing any understanding of Java. You just need to understand, okay, I need to set up, for example, like an HTTP request, and I want to give it like the the host name, the port, etc., URL. Whereas the other two tools, they are requiring knowledge of Java.
So this one doesn't require any programming language.
No, this is just about setting up the web requests or the connections so you can do the load testing.
Just utilize the information and hit go.
So you just create the test plan, hit go, and then it will just like log the results or graph the results for you then. Yeah.
Do you have these many test? Are there spot test cases in the test plan? Whatever the harmony, glory, and all this, are those test cases?
So what I did for this, because the application that I'm demonstrating, I wanted to like show you like 4 different use cases. So the first one was something working okay, the second one was where it was leaking memory, the third one where it was like just taking up too much CPU time, and the fourth one where it complains if it's got too many concurrent resources. So I just created that test plan based on those 4 scenarios that I could then demonstrate. But I suppose in a business situation, you would have you'd have a flow through your web application that like a user journey through the web app of the different URLs that the user would hit. And I would normally go about creating a test plan based on those user journeys. So for say something like Jaguar, it might be, okay, I'm going to the home page, then I'm picking a model of car, then I might go and investigate a particular trim level of that car, and then I might click on, say, book a test drive or something like that. So so the business would create user journeys of how they expect somebody to visit that website and use that website, and those user journeys would then feed into the test plan for covering the ways that the business expects the users to do so. I mean, also, suppose they run Google Analytics, then they could even use Google Analytics to say, okay, these are the most popular URLs, and this is the journey that most people are taking, and so you could generate your test plan based on the Google Analytics data, because that would then give you a more representative test plan of what those users are doing from real world analytics data as well.
Test suites and test cases on your test plan, just like any other functional testing. Can we also do with this?
Sorry, what was that again? Sorry.
We have under a test plan. We have different test suites.
That's right. Yeah.
So under each test suite, again, we have test cases.
Yeah.
So in this, can we also do that?
You could do. I mean, if the test suite is about going through an application in a given order, for example, accessing different web pages in a particular order, you could then create a load testing plan, a load testing suite based on that test plan also. Yeah.
Can we also run these overnight and get the report, like any other functional testing reports that we get with continuous integration tools? Can we integrate this as well?
Cool. So, yeah.
You can create generated scripts to do whatever you want test. You can actually automate them.
Yeah.
You can also, something we did at the test back on the course of JMeter last edition, actually parameterise and visualise variables, so you can actually put those into command line invocation. So you can actually change your test patterns from point to point.
Cool.
Yeah, it was very neat.
Yeah. So I guess you could get a Jenkins job to kick off a JMeter even, couldn't you, I suppose, yeah. That's really cool, yeah. I like that.
Yeah, just a question. Is there any other performance testing tool which uses a GUI layer for doing performance testing, which simulates the user condition, real-time situation, rather than HTTP requests or APIs? Do you know any performance testing tool which makes use of the UI to do the load testing or performance testing?
Not offhand. I'd have to do a Google and see. So it's yeah.
So it can be run automatically as well. Can you get it to do it forward?
Open the browser.
If you're using tools like Load and that, you can actually drive the GUI to that for passing exorbitant cost.
Yeah. Do you mean something like Selenium, for example?
Yes.
Yeah.
You can, you can actually link Selenium to
Yeah.
Real-time.
actually executing JMeter through Selenium.
Oh wow.
That works.
You could test it by
This is also same. It is getting
Yeah.
HTTP request, but there's also some sort of browser.
Do you mean? I mean, I suppose thinking about it,
If you do,
are you saying that you want to see a browser actually, the clicks on an actual browser. Is that what you're saying?
Yeah.
Selenium, yeah.
To compare between two or three browsers.
It'd be Selenium then, wouldn't it? I think, yeah. Or Browser Sync is another one. I think if you want to like test across different devices and stuff, there's something called Browser Sync that will fire off requests on different phones and tablets for you. I think. But I think.
It's very good.
What was that? Sorry.
Multi-browser. Multi-browser.
Yeah.
I'm using. I was only able to use it manually, but even then, you didn't have to download all different types of browsers onto your machine. It would do that all for you.
Nice.
So that's a big overhead in itself. Like you have Firefox and Chrome and all the others, and then all the different variations. But it also was a cross-device thing as well, so you could try it on tablets and phones. And when it was set up, I just went and tested randomly because where I was testing, which was Leeds Building Society, their firewalls basically and security meant that I could not run it automatically.
Oh man.
But I would have liked to have been able to see its scope when you could run it automatically, because the idea was that you'd be able to run it in sync across all the different browsers and see where it popped up.
Nice.
So yeah, I'd really like to get my hands on that, on
Yeah.
a site where you could actually use it.
Can I ask a question?
Of course you can, yeah.
So, I'm getting to grips with understanding this, JMeter.
Yeah.
And you refer it back to the other page. So that's the code,
That's the Java code that
Java code.
we're testing.
Yeah. So you're a developer.
I'm a developer, yeah.
So for you can do presumably both parts of this, like you said before.
Both parts, so the load testing and then the sort of like code analysis and using like the memory tools to and the CPU profiling to then work out where in the code the problems are happening.
Yeah. So if you were just a tester and you hadn't got the development knowledge or skill,
Yeah.
at what point do you then sort of throw this back to the development team and say, well, this is what I've tested. You need to go and sort it out.
So I think for somebody that's purely a tester, they'd probably be focusing more on like this JMeter side of things, where they're creating like the load test plan and executing the load tests, but they're not delving into like the inner workings of the Java virtual machine so much.
I've seen this approach being used more by developers.
Yeah.
Particularly in an agile environment.
Definitely, yeah.
Actually working close with the testers and technical testers, then it's going to become more apparent and you're going to be able to upskill. But generally speaking, into that much detail.
I was working before I did something. The tester doesn't have a terminal. We haven't used JMeter. We are using JProfile, just like just give this parameters, hit the play. And after 1 hour, 2 hours, it generally goes handled with the manager.
Okay.
And that input is very easy. It's even a layman who doesn't have knowledge to understand what we are expecting and what. So sometimes the requirement comes from the customer that we actually want, for example, 1,000 transactions per second. We have to pass the requirement. Then after, if we succeed and increase, let's say our transaction going to 300 transactions per second, and after 600 is failed, we can say, oh, we have passed your requirement, but we can give 500 more. That's how we need to scope that requirement. Otherwise, the tool generates all the report in the PDF format.
It's JProfile.
Oh, cool. That's another one to look at too.
But that's paid.
This is free,
So
yeah.
you have a load result, which is again a paid version.
Yeah.
Then you have a different various of trying to get all the performance stress, load, RAM memory, using cloud users or concurrent users, so many, then go for the paid users.
So mostly company buy this. If they want to have every user, like mostly banking sector, they have this split. The pay version. And you just buy that and get the report.
Like e-commerce and like integrated applications, like banking sector, insurance sector, where you have a business users. They do a performance as a different
Yeah.
the performance tester need to have this knowledge.
Yeah.
But again, when we see only the Java flavor, but in the market you have a .NET, C#, and .NET. So that is again a challenge for the tester.
Yeah.
So if you say that I'm a performance tester, and if I go for one application, they are only on the Java. But when I'm looking for the new roles, he is looking for the .NET.
Yeah.
So that
Yeah, I see that a lot.
I have a performance knowledge, but I don't have a .NET knowledge. So those are the challenges when you look for the only the performance tester perspective. Again, that too again, when you come to the automation, I can be more Selenium, QTP, and open source tools. So again, those are the challenges.
Cool. Any more questions, please, then, or are we okay?
In your experience, I think, like Venkat has already touched upon it, requirements to be tested as this performance aspect is concerned. Do the companies then dictate the tools you use, or are you then given the freedom to choose what suits best? Because these are open source.
These are open source. Yeah.
It is probably no cost to the company anyway.
Exactly.
The skill set anyway.
Yeah.
But then there are companies who actually say, well, we've invested about £1 million in such and such tool that does
Yeah.
this, that, the other. Then are you then required to use that, or do you then have a case where you can convince your client process to say, well, actually, this is much easier, there's more demand and more people who have got this skill set.
Good point. I think it would depend on the company in question where you're working and what the culture is there and what people's attitudes are to using open source, really.
And how have the companies sort of approached this aspect of this aspect? Because yes, they are into online business. This has to be one of the key criteria. But how much focus or how much importance is this aspect given compared to the functionality or look and feel?
I think in my experience, it tends to get sort of like right at the end, at the last minute, would they focus on this as a rule in most companies that I've worked at. So it's like normally they just like develop the functionality, and it's only like towards the end of everything that they'd think about performance, which I don't think that's ideal. I think ideally this should form like part of the definition of done of a sprint if you're working agile, is to make sure the performance is up to scratch.
I think it depends on
Yeah.
the company.
Yeah.
Company is maybe maybe product-based company, they have a center of excellence working on their performance.
Yeah.
Oracle Analyzer.
And then I guess also it depends on what you're working on in a sprint. So if you're working on sort of like low-level stuff like the framework, this is going to be a lot more important than if you're just like, say, developing components that are using like a known architecture. Because when you're developing like the underlying framework that's performance critical more, this is going to be very important, whereas it's going to be less so if it's just developing a new component on top of an architecture that you know well.
So what trumps? So in case if you've got a piece of functionality which is not performant, what trumps which item trumps the other?
Which item trumps the other? I think it's a balancing act between the two, really.
But there will be someone who has to give way. So you've got a feature which is crucial, but it is
Yeah.
basically could easily say, you could basically analyze it, say, yeah, that's the code, say, this, that, the other. It's a lot of effort involved. Somebody has to give it.
Yeah.
Has that sort of conflict? Do these conflicts occur on a regular basis? In your experience?
In my experience, only very rarely, I think. And then, that's where things like caching might come in. So if you've got something that's not performant, then it's often a lot quicker to put in some sort of caching, such as, I don't know, if you're in Java, it might be EH cache, even something like Akamai in front of your application to improve performance. There's other things like there's like a varnish cache that can sit between your web app and the web server as well, for example. So again, if the application is performant, it's not always the end of the world if you can use a caching solution to improve performance, rather than just throwing it out as being not performant completely.
Now, in terms of market, in terms of your job prospects, because you get new tools coming up every few months, does this sort of play? Does it become challenging to keep up with the technology, because people or companies, especially startups, they like to experiment with new things, which are much more sort of new, new and shiny, does it miss out? Does that, have you ever sort of seen wherein there are more people with more skills or other varied skills rather than having, now in terms of testing, if you consider a manual tester, there is no tool knowledge as such which is of prime importance to them. As long as they are able to reason, there are many aspects of manual testing which are applicable. So they can actually go and fit into any work. Do you find yourself then limited to a specific tool set, or are the skill sets that you have, not just in terms of a particular tool, but in terms of knowledge behind those tools, are they easily transferable to other tools that use different technologies?
I would think at least the concepts behind them are. So, I mean, it's like, for example, a load testing tool, whether it's JMeter or something else, it's always going to be about firing lots of requests at an application, for example. So, you'll have like concepts behind that can be applied to any tool that does that sort of thing. In that, okay, so I need.
Could be some different terms. Here we say threats, broken up as many users, deep users, but the response time, throughput, and all this comes as the UI will be different. The way of navigation. The concepts are the same.
So it's like once you understand the concepts, it's then a lot easier to learn a new tool that you might not have come across before than if you were just starting from scratch and you didn't know the underlying concepts behind it.
I think recruiters would basically tell us what sort of demand there is in the market. We basically, because I know for a fact that when it comes to data warehousing testers, I have faced a lot that there are not many in the market, and they basically do want people who have got these specific skill sets. And I'm not sure as to what sort of market you look at, because I have got no idea about this. Coming from a developer background, I can relate to many things here. But again, not familiar with any of the tools. I have heard of it, never used it, never needed to use it. But I'm sure you will have many clients coming up with many different array of sort of tools. Are there any 3, 4, 5, 6? How many of them are market leaders? Yes.
There's quite a few that I've come across over there. JMeter, Eggplant. I think, well, my experience with recruitment performance testers is that generally, if they're contractors and their projects are shorter than testers, one of the reasons why I started with pre-testers in the first place was because I noticed that generally there were always quite long contracts, which is quite an attractive thing for a recruiter, to be honest. With performance testers, it wasn't always the case. Well, we've spoken about it a little bit, but it can be one of the last things you do on a project before something might go live, and it doesn't necessarily take as long to do that type of testing as it does to do functional testing.
And it then might be something that either a tester or a developer that's on that team has knowledge of that they can then just utilise at that point in the project rather than even needing a contractor in some cases, I suppose. Yeah.
I think generally, like I said, it's short projects. They have to be able to use multiple tools. So if you do just sort of, if you like, sell yourself as a JMeter specialist, then obviously you might not always consistently get work.
No.
You probably have to wear the hat.
Is that why they're pricey?
Well, that's the thing. Anything that is short in supply is always higher in
It's because he's deemed as a specialist.
Yeah.
So when you look at it, it doesn't. I mean, looking at Jay, it's the first time I've seen Jay, but it looks. I can understand.
I've only just scraped the surface of it actually tonight. Yeah.
Possibly the past, yeah.
So it's like, this is just like scraping the surface of what it can do. It's like even in work we've only needed a small fraction of what it will actually do.
For those who have been to a few of these, next time I'll put a link on the meter to some slides easy to use on the ministry text.
Yeah. Actually, that as well.
No, I'll put it on the meter.
Excellent.
Also, I'll put an intention as a podcast with both points. Talk about those performance tests.
Oh, cool.
Thank you, Ruth.
Oh, cool, thanks.
Thank you very much.
Cool. Thank you.